Morning guys. Today we're going to take a look at page 7 of the Unit 6 Classwork packet. The topic for today is the circumcenter of a triangle. Now before we get started, I want you guys to understand what the word circumcenter actually means, okay? Center, we're all familiar with, right? It's like a point in the middle. Circum, the prefix circum actually means around. So when we talk about the circumcenter of a triangle, what we're actually talking about is the center of a circle that's drawn around a triangle. All right? Just as a rough example, here, for example, is a triangle. And if I were to draw a circle around this triangle, okay? The center of that circle would be called the circumcenter because it's the center of the circumcircle, okay? So that's the big picture here. That's where we get this name from, okay? The circumcenter is the center of a circle that's drawn around the triangle. Now, what exactly is the circumcenter? The perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. The circumcenter is always equidistant from the vertices, otherwise known as the corners of the triangle, okay? So if you guys take a look at that diagram that they give you right there, the perpendicular bisectors, those, you know those because those are the things that go like straight across to the sides at 90-degree angles. So in that diagram, I would say that DP, PE, and PF are the perpendicular bisectors, right? Because what they do is they go straight across to the sides at 90-degree angles and they split the sides into two equal parts, okay? The circumcenter, that's where the perpendicular bisectors intersect. So take a look at those three segments. What point do they intersect at? They intersect at point P. Now, when it says list all congruent segments, here's where we got to be careful, okay? The circumcenter has a special property, okay? The circumcenter has a special property. Its special property is that it's equidistant from the vertices. So from the circumcenter to each corner is the same. So the congruent segments in this particular triangle would be AP, BP, and CP. Let me say that again. AP, BP, and CP. All right, those would be congruent because they're all equidistant from the circumcenter and from the vertices. Now, let's take a look at two examples of how this would actually work in a problem, potentially on a Unit 6 test or EOC or something like that, all right? So let's start off with example number 1. All right, what does this look like? All right. Sorry about that. All right, so it's TXU and then YV and then WZ. Okay. Okay, and they give me some information here. So let me put that information in the diagram. All right, 15, 19, and okay. All right, guys. So, oh boy. Here's the thing. The circumcenter problems are actually not all that difficult if you make sure you go ahead and put everything you know in the diagram first. So let's go through that step by step, okay? The circumcenter, which is this point right here, point C, that's where the perpendicular bisectors intersect. So notice what I've done is I've actually put 90-degree angles there to remind myself that these pink lines that go straight across to the sides, they actually intersect at 90-degree angles and they split the sides in half. Now think about that. Hold on. I said they're perpendicular bisectors, right? So that means that they split all the sides in 2 equal parts. So that means right away, because this whole thing is 34, what's each one of these pieces? Each one of those pieces I know has to be the same, which is 34 over 2, also known as 17. The same applies over here. If this piece is 19, because this is a perpendicular bisector, so is this. Last but not least, what's the special property of the circumcenter? According to the notes we just took, the circumcenter is equidistant from each corner, or equidistant from each vertex. So what exactly does that mean in plain simple English? What that means is that each one of these orange lines that goes from the circumcenter to the corners is the same. So I'm actually going to put tick marks there. All right? And because I know one of them is 21, the rest are also 21. Isn't that nice? All right, so with that being said, let's go through and actually fill in some of the information they're asking us for. Okay, so the first thing they ask us for is TU. Well, TU is just these two added up, which should be 38. Next up, let's find VY. Okay, where's VY? VY, we already said that was 17. We're on a roll here. Then, let's look at UZ. UZ, we already said that was 21 because we wrote in everything that we knew. WV, all right, so over here, this one's going to be a little bit tricky, and here's why. What kind of triangle do you guys see right here? Does anybody see a triangle? I see a right triangle. When I have two sides of a right triangle and I want to find the third, what theorem should I use? The Pythagorean Theorem. In this particular case, they've given us a leg and they've given us the hypotenuse. So what I have to do is actually solve for the other leg. Here's how that would work. 15 squared plus b squared equals 21 squared. That means 225 plus b squared equals 441. Subtract 225 from both sides. So that becomes 11, and that is b squared equals 216. So b equals rad 216. If you're actually wanting to simplify that further, you could, right? And like I said, this is rad 36 and rad 6. So in other words, this is just 6 rad 6. I know that was a little bit much, right? Oh my God, a Pythagorean theorem problem inside a circumcenter, but that can happen, all right? It can happen. Now, if this piece right here is 6 rad 6, that means that this piece over here is also 6 rad 6. So if I have a 6 rad 6 and I have another 6 rad 6, how many rad 6s do I have in total? Well, 6 plus 6 rad 6 plus 6 rad 6 would mean I have 12 rad 6. So TV would actually be 12 rad 6. All right. Again, I know this was a little bit involved. All right. There was a lot going on in this particular problem. That being said, each one of these problems has parts that will be simple. There'll be parts that are just saying, oh, it's a perpendicular bisector, so it splits a side in two. The hard part is going to be the Pythagorean Theorem application. That's where a lot of people get stuck, all right? Don't stress out too much about it, but let's try one more example together and make sure we're all on the same page, okay? So let's take a look together at example number 2. All right, so example number 2, once again, surprise, surprise, we have a triangle. Okay, we've got, all right, CFD, then that's BG, and that's E. And they all intersect at H. Alrighty, so let's do this, let's do that. Okay. And then, notice guys, I'm actually using a different color each time for the part that goes from the circumcenter to the vertices, and that's actually intentional. It's to help me keep all the different lines, or segments in this case, straight. No pun intended. All right, and they tell me a couple pieces of information, right? They tell me this is 7. They tell me that this is 13. They tell me that this itty bitty piece right there is 3. And they tell me that this whole thing is 24. Okay, so with that being said, let's first start to fill in what we know. First of all, I know that these blue segments are perpendicular bisectors, which means that these right here are all 90-degree angles, okay? That may be important later on when we take a look at how to apply the Pythagorean Theorem, potentially. All right, next up, let's remember that because these are perpendicular bisectors, what do they do to the sides? They actually make the sides split into 2 equal parts. So if this is 7, so is this. If this whole thing is 24, each of these pieces is 12. Last but not least, what's the special property of the circumcenter? The special property of the circumcenter is that it is the same distance away from each corner, or the same distance away from each vertex. That means that if this is 13, so is this, and so is this. All right? With that being said, let's see what we actually know. GD, we already got it. Look at that. It's 12. Look at that. That would be 1 point on a test. Now let's take a look for BC. Where's BC? BC. There we go. So 7 and 7 together make 14. Then to find EH, let's see. EH. Okay, now this one might be a little bit more difficult, okay? Notice this is where we have to apply our Pythagorean Theorem. I have a right triangle here, a leg is 7, and the hypotenuse is 13. So what that means is I have to do 7 squared plus b squared equals 13 squared. That means 49 plus b squared equals 169. Subtract 49 from both sides, and I get b squared equals, what is that? 120. So b equals rad 120. And of course, could I simplify rad 120? Yes, I can. What's a perfect square that goes in here? I think it would be 4. So that becomes 2. And this also has, does it have any more perfect squares? 6, 5, 3, 2. No. So I could just leave it as 2 rad 30. Okay? So this right here is 2 rad 30. Or honestly, guys, I would accept rad 120. If you really wanted to, I'd be fine with that. Okay? Then they asked me for FD. Well, once again, Pythagorean Theorem, I have a leg and I have a hypotenuse. So I would have to do 3 squared plus b squared equals 13 squared. That means 9 plus b squared equals 169. Subtract 9 from both sides and I get b squared equals 160. Take the square root of both sides and b equals rad 160. The biggest perfect square that goes in is 16. And so the square root of 16 is just 4. So I would get 4 rad 10 for FD. Again, I know, guys, that was a little much, right? Even for me. Oh, no. That's better. Even for me, that was a little much, okay? That's a lot of Pythagorean Theorem in one problem. Last but not least, CD. Well, if this is 4 rad 10, this over here is also 4 rad 10 because this is a perpendicular bisector. And what's 4 rad 10 plus 4 rad 10? Oh my gosh, I have 8 rad 10s. Okay? Again, don't freak on me, all right? I know this was a little bit rough. I know, especially the Pythagorean Theorem parts, they're a little bit tricky, okay? So don't stress out too much. What I want you guys to focus on is that no matter what the situation with the circumcenter, you're still going to have some parts that are easy where they just ask you to find apart by dividing by 2 or multiplying by 2 or saying that something's the same as something else, okay? So don't stress out too much. This will be okay and it'll get better with practice.